We're going to look at integrals that have radicals of this type. A squared minus u squared, a squared plus u squared, and u squared minus a squared, where a is a number and u is a variable. And so what we're going to use trigonometry. I want to use the trigonometric identities, the Pythagorean identities. So I know that cosine squared theta is 1 minus sine squared theta. And we're going to use this when we have a squared minus u squared. We're going to use secant squared theta is 1 plus tangent squared theta. And we're going to use that for a squared plus u squared. And then tangent squared theta is secant squared theta minus 1 when we have the form u squared minus a squared. And I'm going to show you, and here u is our trig function. I'm going to show you how we can use them in these 3 different cases. The first case is when I have the square root of a squared minus u squared. Well, what I'm going to do is I'm going to let u equal a sine of theta. And then what that means is that the square root of a squared minus u squared equals a cosine theta. And I'm looking at negative pi over 2 to pi over 2. And this is fine, it's positive, cosine's positive in all those places. So here, if this is my theta, if I look at a triangle, what I have is I say u is a sine theta, which means that sine theta is u over a, which means it's opposite over adjacent. And here, to find the last side, is going to be the square root of a squared minus u squared. So there we also have cosine is radical a squared minus u squared over a, which is where this definition is here, and that's how we can use it. Our second case is when we have a squared plus u squared. In this case, we're going to let u equal a tangent times theta. And that means that my a squared plus u squared is a secant theta. And remember, secant's one of our cosines, so this is also going to be from negative pi over 2 to pi over 2, and that's where it's going to be positive. So here I'm looking at, here's my theta, and u is a tangent theta. That's tangent is u over a, or opposite over adjacent, which means that my hypotenuse is a squared plus u squared, and that does give me secant being a squared plus u squared over a here. So that all works. We have one more case. In this case, what we're going to do is we're going to look at u squared minus a squared, and what we're going to do is we're going to let u equal a secant theta. And so then I have 2 choices. I have my square root of u squared minus a squared equals a tangent theta or negative a tangent theta. And here it's a tangent theta if u is greater than a. And then I have my theta between 0 and pi over 2. And if my u is less than negative a, then that's between theta over 2, pi over 2 and pi. So here's my theta. I have a secant theta, so it's u, which is hypotenuse over adjacent, which gives me this side as u squared minus a squared.